If we're going to solve the system using the substitution method, our first step is to solve one equation for one variable. But in this example, that's already been done for us. Now we just take the expression, the negative 3x plus 7, and substitute it in the other equation for y. So when I write that other equation, 4x plus 2y, I'm going to set a set of parentheses there and then substitute inside of that the negative 3x plus 7. Now we have a linear equation with one variable. We can just go ahead and start solving it. Distribute negative 2x plus 14. Combine like terms. Negative 2x plus 14 equals 16. Subtract. Negative 2x equals 2. And then divide by negative 2. So x equals negative 1. I'm going to save that because now we're going to need it. We're going to plug that back into one of the original equations. I'm just going to go ahead and plug it back into that first equation. Y equals negative 3x plus 7. And again, because I'm going to substitute that negative 1 for x, I use a set of parentheses there as a placeholder. Then plug in the negative 1 and start solving. Y equals 3 plus 7, so y equals 10. Now we have the x value and the y value, but we're not done. Our last step is to write our solution as an ordered pair, which means a set of parentheses with a comma in the middle. The x coordinate is negative 1 and the y coordinate is 10. Let's do it again. This time when we look at the system, it's not already solved for one variable. So what I'm going to do is take the easiest one, this equation, and I'm going to solve it for y. To do that, I just need to subtract 2x from both sides. That means y is equal to 5 minus 2x. And I can substitute this expression in the other equation for y. So rewrite 3x minus 3y using a set of parentheses. Then substitute that 5 minus 2x and start solving. Distribute. Combine like terms. Add 15 to both sides. Then divide by 9. X equals 2. Great. Now take that and plug it into one of the original equations. I'll just plug it into the first one. 2x plus y is equal to 5. My x is 2, so 4 plus y equals 5 means that y is 1. Almost done. Write your solution as an ordered pair. The x coordinate's 2, the y coordinate's 1. Last one. And when you first look at this, it probably looks like an elimination method problem. However, the directions say to use the substitution method to solve it. So that's what you have to do. I'm going to look at these two equations and I see that the second equation has all even coefficients. And the smallest one is that negative 2. So I'm going to solve this equation for y, which means first add 6x to both sides. You'll have negative 2y is equal to 6x minus 14. Then divide everything by the negative 2. Y is equal to negative 3x plus 7. Now we have it solved for one variable. I'm going to take that expression, plug it into the other equation for y. So when I rewrite that top equation, 5x plus 2y, I use a set of parentheses, and then plug in my negative 3x plus 7. Go ahead and solve it again. Due to the limited space, I'm going to go through this a little quicker. Combining like terms, we'll get negative x plus 14 equals 12. Subtract 14, so negative x equals negative 2. That means x is 2. Take the x, plug it into one of the original two equations. I'll just take the top one. 5x plus 2y equals 12. My x is 2. Then start solving. Subtract 10 from both sides and y equals 2. 2y equals 2. Divide by 2 and y equals 1. And there we get our solution again is 2, 1.